Hey, welcome to Calculus 2 lecture on integrals resulting in inverse trigonometric functions. In this video, I'm going to introduce the formulas we'll be using and provide two basic examples. So the formulas that we are given for this part of course are to do with arcsine, arctan, and arcsecant. We'll be focusing on arcsine and arctan today. If you have a keen eye for triangles, you are probably noticing that the sum of squares or the difference of squares, all shuffled with a square root, feels very Pythagorean. And you'd be right. If you wanted to explore the connection between arcsine, arctan, and these algebraic expressions here, I would suggest that you just draw a right triangle and see what happens. I think you'll be pleasantly surprised. Okay, if you don't want to do that and you just want to keep chugging along, I want to start with a comment on notation. When we say sine to the -1, we mean arcsine. It's a function. So arcsine of x is an angle. The sine of that angle is the value x. Okay, so that's what we mean by arcsine here. We do have other notation involving trigonometric functions raised to a power. So for example, sine squared of x, that actually does mean take sine of x, whatever that value is, square it. Okay, so there's a little bit of mixed messaging here. I wasn't at the meeting when that was decided, but just to clarify moving forward. I prefer arcsine. It's crystal clear. So I'll use both today. Our first example, we're asked to integrate 1 over the square root of 16 minus x squared with respect to x. And so this has the form for arcsine. It's our job now to determine the relationship between x and u and what the value of a is. So I'll start with a because that's pretty easy. And we see that a should be 4. If a squared is 16, a is 4. Okay, no problems there. With x, it just would appear that x has been simply replaced with u. So somewhere someone used the value or variable u, and then in this problem, they're like, oh, I'm feeling like the letter x today. And yeah, I agree with that. There's really nothing to see here. I will warn you that this really is a U substitution. And we're going to see that in the next example. So just get used to the idea, dust off your U sub cobwebs and get ready to just have the mindset of U substitution when applying these formulas. Okay, so to me, this is a plug and chug. We know A, X is U, no problemas. We should end up at arcsine of x over 4 plus our constant of integration. And I like to write ARC-SIN for arcsine. And that's the end of the problem. In this next example, we're going to be feeling the U substitution. So we're asked to integrate 1 over the quantity 16x squared plus 1 with respect to x. And this is going to follow the form resulting in arctan. So again, it's up to us to say what is the relationship with the integral provided or the integrand and its structure A and U and all that. So I think one thing to notice is that this is not really given to us on a silver platter. The A and the U are switched. So A squared is 1, meaning A is 1. And we see that U squared is to do with 16x squared. So if U squared equals 16x squared, then U should be equal to 4x. And we need to be careful here because if U is 4x, then du is 4dx. And we don't have a 4dx as part of the integrand. So we need to be careful. I always like to solve for dx if it's not clear like that we have a 4 there. We don't, So I'm going to say 1/4 du equals dx. And to me, that keeps my brain focused. And I won't forget the 1/4. I'll be good to go. All right, so let's rewrite in terms of u. So I've got 1/4. I pull that out of the integral because I can, because integrals are linear operators, which is awesome. And I'm going to have du over u squared plus 1 squared. And this looks just like the structure I need. So in terms of integration, it's just 1 over a, but that's 1 over 1. I get arctan of u over 1. Again, a is 1. And everything gets hit with that 1/4. Don't forget your integration constant. We can clean this up very easily. I divide by 1, that does nothing for me, and I know that u is 4x. So I end up with a quarter arctan 4x plus the integration constant. And I like to write ARC TAN instead of tan to the -1. So that's it. Those are your two basic problems to introduce you to integrals resulting in inverse trig functions.